All right, welcome back everybody. We are moving into project 9 of our Arduino starter projects, and this one is the motorized pinwheel, and it's one of the first times we'll be looking at a couple of different components. One is the motor and the other is the MOSFET transistor, and we'll look at more about this here in just a moment. But first, as we dive into the code portion of this project, the code here is going to be extremely straightforward. So as we look at this, we have our setup and our loop, right? Standard stuff, nothing too spectacular there. The first variable that we are going to declare is our switch state. And we're going to have a button on the board, and that button, when the user presses it, the motor is going to start going. So we need to store the state value of the button being pressed into a variable, and that's what the switch state's about. Next, we are going to set up the motor pin. In this case, it's going to be our pin 9. And this is what we are going to use to write out to allow the motor to start up. Now, this pin is going out to the transistor, not to the motor directly. And in this project, the trickiest thing is going to be understanding the transistor that pin 9 is truly going to. That really allows the motor to spin, because again, this pin 9 is not going directly to the motor, even though when we start pin 9 is when we put pin 9 high, that's what's going to start the motor. And we'll look at more of this in a little bit. I know it sounds confusing right now, and that's because it is going to be a little bit tricky, but we'll take a look at this quite a bit throughout this presentation, as well as the walkthrough of the board. So next, we have our switch pin, pin 2, and this is just the pin that we're going to read the button input on, right? This is what we're going to read, this pin, pin 2. We're going to read whether or not the user's pressing the button or not. That's it. And so for our setup, we really only have 2 pins to initialize. One is the motor pin. We need to supply that or configure that as an output, right? So we're going to be writing to pin 9. So we're setting that up as an output pin. And we're going to be reading in from pin 2, our switch pin. And so we set that one up as an input. That's it. That's all there is for the setup on this one. And when we drop into the loop, that's going to be as equally straightforward. The first thing we're going to do is we're going to read from the switch pin, which means we're going to read whether or not the user's pressing the button or not. And we're going to save that into the switch state. And so we know that the switch state will either be high or low. It'll be high if the user's pressing the button, and it'll be low if they're not. So we're going to look to see if the switch pin is high, if they're holding down the button. And if it is, we're going to write to that digital pin 9, and we're going to turn it on, essentially, right? We're going to write high values to that, right? So the high voltage to pin number 9 if the user's pressing the button. Otherwise, if the user's not pressing the button, turn the motor pin to low, right? And turn it off, essentially, and don't rotate the motor. And that's it. That's the entirety of this code base. Very simple, very straightforward. We've seen this stuff before in the past, so it shouldn't be tripping you up. Really, it's configuring the pins and either reading from them or writing to them. Now, what is going to be tricky on this program or this project is understanding the transistor. So if you look at the board in the book, you'll notice there's a 9-volt battery going to the motor, and then we pull in the 5-volt from our Arduino. And so when we have this 5-volt, 9-volt kind of contradiction on the same board, we have 2 different power supplies giving input on different voltages. We need to account for that. And that's where the transistor comes in. So let's take a look really quick at this transistor, just to understand it a little bit, right? MOSFET, I'm pretty sure that's how you say it. Metal oxide semiconductor field effect transistor. It's a transistor. And what really makes this transistor special is that it has the gate, the drain, and the source. Those are the 3 legs on the transistor. But really, let's first understand what transistors are necessarily used for. And what they're used for is pretty much converting different currents within a board, right? So if you have high power from one input and you need low power in some of your other circuitry, or you need that power to get amplified over time, this is where transistors come in, right? They use audio as one example, right? If you need to kind of increase the volume, sort of. But it's really kind of switching between those power loads. Another way to look at this is, amplification. This is where we're talking about the audio. If a power source comes in at 5 volts and it needs to convert it to 9 volts, then that's where transistors fit in to amplify that power. Now again, bringing in 5 volts, amplifying that to 3,000 volts, that's not going to work. I mean, depends on what transistor you have. But generally speaking, this is where transistors really fit in, right? And so because we have the 9 volt and the 5 volt on our circuit, this is what brings in this transistor. And we're going to talk about how we're going to use it here in just a bit. But again, one thing that I do want to point out, DC to DC converters, if you have two DC circuits that have different voltages, again, this is where the transistor comes in, right? And this is what we've already spoken about, but it's looking to kind of make that a nice, subtle transition from one voltage to the next. And that's really where transistors come in. But what I want to do now is talk about how we are actually using this MOSFET transistor. So the G gate, or the gate pin, if you're looking at the diagram in the book, it's the very top pin. And that pin really, if you supply power to it, it essentially turns on the transistor. You can think of, if the gate pin gets power, the transistor gets turned on. And if you remember in our code, we set our voltage high on our digital pin 9 when the user's pressing the button. So here, when the user presses the button, for all intents and purposes, we turn the transistor on, okay? And that's what the gate pin is actually doing. So this pin right here, this D pin, is the one that I really want to focus in on. But first off, you can see down at the bottom of the view, this is an image directly taken from the course book, from Arduino's project book. And what we do with pin 9 that we were talking about a moment ago is, when we supply power to that, we've essentially turned on the transistor. Now, what does that really mean for us, and why are we talking about this D pin? When the transistor's turned on, it allows power to flow from the motor into the transistor. If we're looking at this diagram at the bottom right now, if the transistor is not turned on, the black wire coming from the motor into the green wire that comes into the D pin on the transistor, right? So if you're looking at the motor, you look at the bottom right, there's that black wire, which is the ground that's coming out of the motor. And keep in mind that the motor has circuitry in it that needs to have power coming into it, and it needs to have that circuit complete and power coming out of it going to the ground. Well, if we look at this diagram right now, the ground coming out of the motor, even though it's going into the breadboard, you can see that it's not going directly into the typical ground that we normally ground our components to. It's just going into a regular slot on the breadboard. So unless the transistor is turned on, what's really happening here, this is the equivalent if that black ground wasn't plugged into anything. If it was completely taken out of the breadboard, if we have the transistors turned off, that's the exact same, meaning that the circuitry in the motor has no ground at all. It's not going, it has no place to go, so the circuit can't complete so the motor does not turn on. Now, what happens when we turn on the transistor, when we give it the power that we're looking at right now, when we give that gate pin power? What that allows to happen is we can now look at sending power into the transistor. And that means that the power from the ground now has a place to go. And so essentially, the circuit within the motor is now able to be completed. Now it has, the ground is actually active to go somewhere. In this case, it will go into the transistor. And the motor circuit is now complete. Now, the one thing in the next, we'll see this in a second, the very bottom leg of the transistor is the source. And you'll notice that that goes to ground. So once we turn on the transistor, this middle pin, this drain, pulls the ground, allows the ground to complete the circuit from the motor. It comes into the transistor, and now it still has to go somewhere, and it's going to go out to the ground. But notice we're pulling in power, the ground, from a 9-volt battery, and we're going out to the ground of a 5-volt circuit. And that's where the transistor makes this a nice and smooth transition between those two power sources. And so here we're talking about allowing that ground to go through, and then, the ground from the motor to go through, and then the transistor goes to the ground. And so now everything's complete. Everything's just fine. And if we turn off the transistor again by letting the button up, the transistor will no longer take the ground input from the motor, and the motor will shut off because the circuit can't be complete. Because if you look at the motor right now, that 9-volt battery has continuous power going into it, but it still stops when we release the button. If we took that ground out from just the random place on our breadboard, and we took the ground from the motor and put it into the ground on the power supply in that outer edge, it would start up. It would run. But anyways, this is where the transistor comes in, and this is why this D pin is so critical to understand. Now, the one other thing that I want to point out here, when we're looking at the whole circuitry, is the diode. And what this diode does is it allows power to pass one way, one direction, right? Unidirectional. And so when that power comes out of the ground, that power can leak into our circuit if it's not kind of controlled and put back someplace useful. Here, we're just putting it right back onto the power supply, and it just helps power our motor. But it only goes in this one direction. If the power tries to go back in the opposite direction against the diode, then it just can't. It's, again, unidirectional. So that's really how this circuit is working, and we'll look at it again as we walk through the actual circuit. But again, I did take this picture from the booklet for the study guide from Arduino. I think it's very useful here to get a good idea about what's happening with the actual power. And so the only thing that's really left to talk about, again, is the bottom pin, the source pin. And all that does is it goes to ground. It's that simple. Just straight, it goes to ground. But anyways, that's it. I think, again, the source code was extremely straightforward. I wanted to make certain that we have a high-level overview of the transistor going into the board walkthrough. I think things will just start to kind of come together once you see the next video on the board. But here, I felt it was a good precursor before actually going through and walking through the board, which we will do in the next video. So we will see you there. Take care, everybody.